Hi, I'm
Hi.
Sophia.
Hi, my name is Grace. I'm also a senior at
Sorry, go ahead, Grace.
oh yeah. Okay, yeah. Hi, I'm a senior at Monmouth High School. I'm also super excited to share all of the tips that we have for you guys.
I'm Sophia. I'm a junior at Monte Vista High School, and I'm also very excited to be here.
Hi.
I'm actually
I'm Darian. I'm a sophomore at Limburg High School, and I am here today.
I'm Akshita, and I'm a sophomore at Folsom High School, and I'm really excited to share my experiences with everyone.
I'm Victoria. I'm a freshman at Deerfield Academy, and I'm super excited to share my experiences.
Great. So now that we've introduced everyone, we'll kind of be moving into the seminar content.
For our first research seminar, we've divided our presentation into 6 key points, with the first being research and a science fair timeline for high schoolers. And so with this, we'll be debriefing when to submit proposals, how to maximize school breaks for time management, how to track your progress, any of the sort. We'll also be going over data analysis paired with examples, as well as an example poster presentation. As a student-run research organization, SparX initiative also offers STEM opportunities and resources, as well as advice for specific research topics, so CS, computer science, machine learning, bio, and mathematics. Finally, as experienced science fair participants and synopsis participants ourselves, we're really excited today to share our experiences from us to you, as well as just teach you about the things that we've learned through our own research. Finally, in the last 10 to 15 minutes, we'll be going over SparX activities, as in how can we as SparX help you succeed in your science fair projects, as well as have a mini Q&A session.
So first we'll kind of be talking about what exactly is research. So as this quote from Hampshire College expresses, research is a process of systematic inquiry that entails collection of data, documentation of critical information, and analysis and interpretation of that data or information. In other words, research is just a process of analyzing what we observe in the world around us and using it to draw conclusions, and also expand general scientific knowledge. So research is not only beneficial because it helps expand our scientific knowledge, it's a very mutually beneficial experience because from a scientist's perspective, it's also a very rewarding journey. So as a scientist, you'll have the opportunity to have a rewarding exploration of a field or subtopic you're curious about. Maybe that's something in physics or mathematics that you've always been wondering about, but you've just never had the chance to explore at school. Well, research is kind of your chance to do this. As a researcher, you'll also have the opportunity to discover or build new ideas, such as if you're doing an engineering project. You'll have the chance to gain independence and confidence in your learning, because research is a very self-driven process. It will enrich your perspective of the world, even outside of your research field, and you'll have the chance to meet many other awesome scientists.
Some examples of local science fairs include research, like regional science fairs, like Synopsis Science Fair, San Mateo's STEM Fair, Los Angeles County Science Fair, Orange County Science and Engineering Fair, etc., etc. For a full list of California fairs, you can see this link below. There are many Intel-affiliated science fairs all over the world. So yeah, check that out. Also, some other research opportunities that are not regionally based are the Google Science Fair, the Conrad Spirit of Innovation, MIT Think BioGenius Challenge, and also Regeneron. I think the last one is discontinued for now, but they might be restarting it soon.
So next we'll kind of be moving into the general science fair timeline. This science fair timeline is kind of written for around California science fairs, such as the Synopsis Science Fair. It could be different for some other research opportunities though. So typically during the spring, summer, or the start of the school year, that'll be around the time when you're determining your research hypothesis or engineering goal. So around this time, you might be reading research papers, seeing if there's anything that interests you in the news and that you'd love to explore further. I think a general tip for this step of the process is just not to procrastinate, because the earlier you start your project, the more time you'll have to explore it more in depth later on in the year. So around the fall or the start of the school year, that's around the time when you'll be submitting a proposal for your project. Again, the time for this will kind of be different for different science fairs, but hopefully by this time you have a general idea for how you want to approach your project, if you're doing a biological science project, how you will get the materials for your project, and just the general model architecture if you're planning on going into a more engineering heavy project. So most of the heavy work for your research will probably be coming into the winter or the spring. Around this time, you'll be performing experiments and improving your engineering model. A general tip is to try and work consistently on your project, so that way you don't have to cram a lot of the work at the end of the season. And also, this is a time to reach out for help from any teachers or upperclassmen. And finally, in the late spring, that's when you'll be focusing on data analysis and preparing your project presentation. And finally, your science fair, either in March or April.
So keeping a research journal. So why should we keep a research journal? It's used to record data, document ideas, and specifically the thinking process. For engineering projects, typically engineering notebooks are required. So yeah, because like I did that last year and we had to use one. And for each entry, fill out the dates, time, events, sketches, ideas, page numbers, and any like other things that you may need. And organization is key, so it's important to stay organized so you know what's going on. And especially since of COVID, we can't really like keep the same journal. Like if you're working with friends, you can't really keep like an actual journal. So an online journal is, you can use that if needed. You can collaborate with peers, and you can print it into a binder later if you'd like that, or if you need to present it to the judges. And yeah, just keep it neat. And some things to document are the table of contents, journal entries, like I previously said, and data that you collected. And on the bottom, it's usually preferred to write the conclusions drawn. That's what I did. And yeah, notes on other research papers or articles that you may have found. And engineering projects involve a lot of sketches, so make sure that there's room for sketches and flowcharts and pictures and questions and ideas. Yeah, so these are famous research journal examples, like listed.
Yeah, so you can kind of see from left to right, this is the research journal of Marie Curie, Da Vinci, Einstein, Edison, and Charles Darwin. So for more kind of realistic student or notebook journal examples, these are a couple if Akshita wants to describe them a bit.
Yeah, so the one on the left, the far left, is mine. I used that for engineering last year. It's just a list of like the different types of screws and all that, because I made a LED ukulele from scratch, so we needed to know all that. And the one on the far right, the one on top, that one's also mine. Those were just class notes because I took an engineering class last year. And yeah, that was really helpful because I was able to like go back and look at the things that were needed for my project.
Yeah, and a couple of these notebook examples are also from my science fair notebook. So you can kind of see that some things that you can record are any flowcharts you might have of your working process, any data that you collect, or just general notes and calculations that you've done.
Now we're going to move on to data analysis. Data analysis is an incredibly important part in any research project. It is the proof for your research and findings, and it convinces the audience why your hypothesis or conclusion is the most accurate. Data analysis is defined as the process of inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information, informing conclusions, and supporting decision-making. So a quotation that we found was, "You can have data without information, but you cannot have information without data," which is said by Daniel Keyes Morgan, a programmer and writer. This quote is pretty straightforward, but it emphasizes that quantitative and qualitative data is critical to gathering useful information in research. So now we'll talk about how you can express your data. Data analysis is most commonly displayed through visual elements like graphs, charts, pictures, etc. While pictures and models simply provide reference to what you did in your specimen, Graphs and charts depict the findings and its relation to the topic that you're researching. An important skill to have is when to know is when you should use what type of graph or chart. For example, line graphs are used to track changes over short or long periods of time. When smaller changes exist, line graphs are better to use than other graphs. Line graphs can also be used to compare changes over the same period of time for more than one group. Bar graphs are used to compare things between different groups or track changes over time. However, when trying to measure change over time, bar graphs are best when the changes are larger, such as days or even months or years. Area graphs are very similar to line graphs. They can be used to track changes over time from one or more groups. Area graphs are good to use when you're tracking changes in two or more related groups that make up one whole category, such as public or private groups. Pie charts are best to use when you're comparing ratios or parts of a whole. They do not show changes over time. And finally, XY plots are used to determine relationships between these different things. XY plots are these kind of three-dimensional graphs you can use on MATLAB or more advanced software. The x-axis is used to measure one event or variable, and the y-axis is used to measure the other. If both variables increase at the same time, they have a positive relationship, but if one variable decreases while the other one increases, they have a negative relationship. Sometimes the variables don't follow any pattern and have no relationship. These are the 5 most basic types of graphs or charts that you would most commonly see in research.
So continuing on with some more ideas for data analysis. For projects with accuracies, especially computer science projects, it can go a long way if you just do a bit more analysis on your accuracy. So some examples of values that you could find are the accuracy, the F1 score, the sensitivity, specificity, and the MCC. So with these values, you can also see how does your model compare with previous research. So again, if you're doing a machine learning project, it can also be helpful to do graphs such as accuracy versus epoch, or the number of trials in your machine learning training, the accuracy versus the dataset size to see if your accuracy plateaus, which would mean that you have sufficient data for your project. You can compare how successful your project is with different data sets or data conditions. And finally, if you have time, you could try implementing a Monte Carlo simulation, which is a way of kind of randomly introducing some variability into the variables to see how your model performs under these different situations. Additionally, if you're making any physical measurements, it can be really helpful to go into error analysis, to just go an extra step and show your judges why your results are reliable. So for instance, you could find the standard deviation and variance. If you know that you're measuring some kind of normal function, you could calculate the z-score or the probability that your data actually has represented something statistically significant. And if you're combining several measurements, for instance, if you're measuring parts of a circuit, then you can use Gaussian error propagation to combine them into one larger uncertainty. So a general tip for data analysis is to read papers in a similar field. That way you can learn how professional scientists analyze and represent similar types of data and gain ideas from there. Next, we'll kind of be moving into a poster presentation.
So here are the important elements to include in your poster. It's important to note that these are only suggestions and that your science fair probably has specified the exact requirements that they're looking for on their website. So make sure that you're checking that out before you start making your poster. So the very first element is going to be your title. And that's the very first thing that your judge sees. So because of this, make sure that your title is concise, clear, as well as attention grabbing. Next is your abstract, and that's really just a summary of your entire project. You could find sample abstracts in medical journals, other scientific journals, and on other places on the internet. Next is your hypothesis, which is the question that you're answering with your research. And your hypothesis should be a statement that your findings either support or do not support. Next are the variables, both dependent and independent, that are in your experiment. And next, the background research about your topic that you've done prior to experimentation to give your judge some context. Next is your data analysis that Kenneth talked about earlier, and this should be in the forms of charts and graphs. Avoid using data tables as much as possible because you want to allow your judge to easily visualize the potential trends in your data. Next is your conclusions. So this is what your data tells you about your hypothesis, whether you supported it or did not support it, and what significance your findings might have. Lastly are your acknowledgements and bibliography, where you'll give proper credit to the individuals and sources that helped you in your research.
Next, here are some tools or software for poster presentations. Microsoft PowerPoint is definitely the most popular. It is super flexible, easy to navigate, and really easy to be familiarized with. Adobe Illustrator, Photoshop, and InDesigns are close seconds. They're really great at rendering high-resolution images and extremely customizable. However, keep in mind that it is much harder to learn how to use and expensive. So if you're working on a budget, Microsoft PowerPoint is a much better choice. Next, some category-specific softwares include LaTeX and BioRender. LaTeX is specifically really great for mathematics papers. It's good at rendering graphs and statistics. And BioRender is great for bio projects, especially infographics and also visuals.
Some tips for creating a poster. So the main goal of a poster presentation is to present your research in a way the judges can understand. Clarity is the number one focus. As such, you have to organize your information clearly so it'll be easy to read. Have logical leaps between each section of the poster and make sure each area should be centralized and focused. Always have varied visuals such as graphs, charts, or photo evidence. Uh, you should include captions explaining conclusions drawn from all visuals, so each visual has a purpose. Make sure you proofread your whole poster and check for grammatical errors and simple mistakes. The physical aspects of the poster has to be cleaned up. Try choosing a symmetrical layout, and for a color scheme, have no more than 2 to 3, and make sure you don't overwhelm the poster with text.
So next is presentation or science fair day. First of all, of course, sleep and dress to impress. Sleep especially is super important because you want to be as sharp as possible for the Q&A session that's probably going to come after your presentation. Q&A is a major part about how your judge is going to evaluate your project, so make sure your brain is in the best shape possible. However, keep in mind that putting awards onto your poster boards or sticking pins from other research competitions onto your blazer is not allowed, because you shouldn't be convincing with your judge with anything else other than the material on your poster board. When you get to the science fair, be prepared to explain every single facet of your research project. I would practice explaining your project in a 2 to 4 minute explanation in sort of like a catch-all elevator pitch, which includes your problem statement, engineering solution, or what you explored, and the major impacts of your research. You should also prepare some commonly asked questions ahead of time and practice answering them. We'll be going over specific commonly asked questions in the next few slides. And finally, troubleshoot everything, especially if it's online. Make sure your audio, video, and any programs you're running or demonstration you're showing are in perfect working order. Being online usually means that there's a strict time limit, so make sure you save time on technical issues and use every minute to better explain your project. And if you have an engineering project, definitely don't forget to bring your model or show the physical project on Zoom this year. A lot of judges love looking at that.
So next we'll kind of be going into some advice for specific science fair categories, such as computer science and machine learning, the biological sciences, and mathematics.
So first of all, what is machine learning? Since the first category we'll be going over is machine learning, I thought that I would give a brief explanation on this. Well, in the simplest terms possible, machine learning is basically when, well, the computer learns by itself. It's unlike a traditional if-else where the programmer tells the computer exactly what to do. To take an example, let's just say you want to teach your program how to diagnose whether or not someone has lung cancer. With traditional programming, you would define all of the rules the computer follows to see whether or not this person has lung cancer. Obviously, it wouldn't be something this simple, but if it was like traditional programming, you would be like, if this user is 85, for example, then say that he has lung cancer. If the user is not 85, then the computer just wouldn't know what to do. However, with machine learning, the computer creates its own algorithm and mechanism to determine whether or not this person has lung cancer, and it adapts to new solutions. We achieve this by asking the computer a large amount of question and answers, feeding it a gigantic database. Just like you would learn a math concept by doing many problems, a computer would learn how to diagnose lung cancer by taking in many training cases. Once you have enough question and answer pairs, the calculation and values are slowly adjusted in their algorithm or mechanism in a process called back propagation. Basically, the computer is given a lot of examples and tries to guess the same the same answer as the example given. When it is wrong, an error is calculated and the values are propagated backwards for the next time. So that's a lot of like confusing words. So a metaphor for this would be like if you were walking down the sidewalk for the first time and you see a lamppost for the first time ever. You've never seen a lamppost before, so you walk like straight into it and you're like, ouch, that really, really hurts. So the next time you see a lamppost, you scoot a few inches to the side and keep walking. This time only your shoulder hits the lamppost and it hurts a little bit less. So the third time you see the lamppost, you move all the way over to ensure that you don't hit the lamppost at all. And that's great because you totally walk past the lamppost. But then this time you see something new, you see a mailbox. And you've never seen a mailbox before, so you walk straight into that as well. And the whole process basically would repeat itself. Since the computer can do millions of calculations at a time, it's basically able to repeat this process over and over and over again until it has this very complicated algorithm that it follows to do incredible things like diagnose lung cancer very, very accurately.
Yeah, so one of the reasons why we're going into machine learning a bit in depth is because it's usually a quite accessible project for students, as to write a simple machine learning program, usually the code is not too heavy, and also because there is a lot of rich information and data on the internet which students can analyze. So if you're interested in getting into machine learning, some great resources are learning Python on the Codecademy website, or also the book Python Crash Course by Andrew Maths. You can also look at machine learning resources, such as Coursera's machine learning course by Andrew Ong, which costs money to get the certificate, but is completely free of cost if you just want to take the courses. You can also look at 3 Blue, 1 Brown, which is a YouTube channel with many useful machine learning videos, and also apply for machine learning classes or any summer programs. If you're interested at looking at examples of machine learning code, you can look at some different projects on GitHub. For instance, some famous examples are iris classification, classifying whether a picture is a cat or a dog, or long short-term memory models. Finally, it's very helpful to read research papers to see what other researchers are working on in a similar field. Additionally, if you're interested in pursuing machine learning, it's important to remember that your data will be the backbone of your research. So before you start, it's important to find as many potential databases that you can in order for you to choose the most optimal one. And this isn't too hard as there's so much rich data already available on the internet. You can also merge different data sets and try training your model on different data sets to see what kind of combination of data would be optimal.
Next, collaboration. A lot of people work in groups, so if you're working with many different people, definitely learn how to use GitHub. No matter how confusing it is, it pays off in the long run because you never know what might crash, and you don't want all of your work to disappear because someone spilled water on your laptop. GitHub also has this free student developer kit of really cool coding software like Unity, where you can explore augmented reality and virtual reality. Furthermore, if you're working in a group, documentation is so important. Make sure you comment exactly what your code is doing because it's very easy to forget when you could be working on this project for months. Many students can continue the projects that they started one year, the next year, and find documentation to be a complete lifesaver. Good documentation also makes it easier for judges to judge your project, so make sure to keep this good habit up. Furthermore, you should ensure that you're working on the same version or update of your coding language as your entire team. Coding languages are constantly evolving, and code that works on 7.1.2 might not work on 7.1.3. Different versions cause a lot of backend errors, and they're the worst ones to fix because you're dealing with code written by a PhD somewhere. So you should definitely remember to use the same coding language. Furthermore, you should record how you set up your TensorFlow for the exact same reasons. When you're being interviewed about your machine learning project at science fair, you should be prepared to explain how you balanced your classes, all your packages and the functions, and your process, like what models you used and how did you evaluate how good your model is.
Yeah, and on the slide, we've put some additional tools that you could use if you're planning on pursuing machine learning in your project. Often people will do code on Jupyter or Jupyter Notebook. You can also utilize TensorFlow, which is a library created by Google, including various machine learning functions. And finally, we have listed some other machine learning libraries, such as Matplotlib, Pandas, scikit-learn, and more, so that you can use these to render visuals or just generally support your machine learning project.
Okay, so I did a biological science and engineering project last year, and I'm also a student tutor in my school's STEM research class. And one concern that I get quite often from students is if my data is quote unquote wrong, as in if my data does not go with my hypothesis or is all over the place, did I completely fail my experiment? And the answer to that is absolutely not. The data that you collect from your experiment, whether it supports or does not support your hypothesis, is always grounds for a great paper or poster. Because either way, as long as you've conducted your experiment properly and are able to rule out all the factors affecting your results that you could not control, you've discovered something that no one has discovered before, and that's good science. And that's exactly what the judges at whatever science fair you're competing in want to see. Judges want to see that you conducted multiple trials within your experiment, as well as made changes to your procedure and recorded those changes as you went along. If your experiment fails the first time, if your initial measurements don't work out the way you expected them to, judges want to see that you fixed all of those issues and demonstrated creative problem solving in that process. Your data is going to be messy and you are definitely going to have outliers in your data, but that's 100% normal. And in fact, actually a good sign that you did not falsify your data. So all these things together constitute great science, and that's what your judge wants to see. So if your data doesn't support your hypothesis, or if your data looks like it's all over the place and messy, don't worry. What counts is how you obtained that data and analyzed it to make conclusions. Now, the next topic I wanted to touch upon for biological projects is possible questions that you could receive from judges at the science fair. And a lot of these questions are actually applicable to other categories as well. The first question is, why did you choose this project and what inspired you? When you're answering this question, it's important to be honest. You want to tell your own unique story and avoid being generic. The second question you could get is, what challenges did you face and how did you overcome them? Like I mentioned earlier, judges want to see creativity in the way you approached challenges. And these challenges could be challenges that you faced during your experiment, while you were collecting your materials during COVID, challenges you faced during data analysis, etc. So make sure you focus more on how you solve these issues rather than these issues themselves. The next question you could get is, what do your findings mean and what is the significance of your research? With this question, judges really want to see why your research and your findings are important to your field of study. What could your findings mean for your area of study in the grand scheme of things? Do they answer a question that scientists have been asking for a long time? With this specific question, you really want to prove that your research was worthwhile and significant. Now, all of these questions are just potential questions, and you're definitely not limited to these questions only. Your judge could also word their questions a little differently, but it's important that you are prepared with your general answers to questions like these.
So the last project type we'll kind of briefly touch upon are mathematics projects.
All right, so here's some advice for mathematics projects. First point, the most important one is that you should always check and show your work. Showing your work is super important because it shows how you reached your conclusion, and it can also make your project seem more legitimate because then other people can see how you did it. Checking your work is also really good since in long drawn out calculations, things often go wrong. And you should at least check your work 3 times if you're serious about your project. And you should also check it in different ways, such as checking it backwards or having someone else check your work. Since if you check your work the same time every time, chances are you'll make the same mistakes as you did the first time you did the problem. Percentages and graphs are also really good for presenting math projects since often the people you're presenting to aren't as knowledgeable about the project as you are. So using percentages and graphs can help them understand your topic better. You should always try to go the least complicated route in your work. No one wants to see you do 1 plus 1 plus 1 plus 1 when you can just do like 1 times 4, and it'll help condense your work and make it easier to read. You should be prepared for all sorts of questions, but the main way you're going to be arguing against them is going to be using statistics and your work, since that's like an easy fix. If they point out a flaw, you can just point out the statistics and be like, actually, these say that I'm correct, and that'll work most of the time. You can also consider interdisciplinary mathematics research, such as math and computer science, math describing natural systems, math plus physics, etc. They can help you get a broader range of topics, and it can help you find a topic that relates more to your audience.
So next we'll kind of be moving into some team experiences, such as things that we learned throughout our projects and things that we wish that we had done in our own research.
Well, one thing that I learned in my project is to never panic when being questioned. When I went to my first research fair, they asked a lot of questions that I didn't know the exact answers to. So I talked about general concepts and it actually went okay for me. So just be confident and everything will be fine.
Yeah, and in general, remember, like if you're being questioned, you've done all of your research throughout the school year. So like you have already done most of the preparations. It's mostly about communicating them. So something that I kind of learned from my projects is that it's super rewarding to just research a topic that fascinates you, even if you're not sure what the outcome will be. And whatever you choose, make sure that you pursue that topic as deep as time or your knowledge allows you. That's one reason why it's really important to start your project early on in the year, because that will give you some time at the end of the project, especially before the science fair, to just go a lot more deep into your data analysis. It's also important to reach out for help.
Yeah, reaching out for help is extremely important, especially if there's something you're confused about, something you want other people to look at to give suggestions and determine areas of improvement. It'll help you improve your project overall. And instead of having the judges do this for you and kind of lose points, you would want other people to help you to get rid of these possibilities.
One thing that I learned is to never procrastinate and not do a major part until the last minute, and leave yourself sufficient time to analyze and interpret your data so you'll be really prepared this way.
Yeah, it's also important to just know your material in and out. So it's a great idea to take a step further and ask yourself divergent questions, such as a mock Q&A before the actual science fair.
One thing I learned was that proper grammar is way more important than you may think. You need to thoroughly proofread your paper and poster to make sure that they're free of any spelling or grammatical errors, and maybe get an adult or friend who's good at writing to read over your stuff for you as well. This is to make sure that you leave a good impression on your judge and that your writing is clear.
And finally, it's important again to, like we can't emphasize this enough, just don't be afraid to ask for help. Having another pair of eyes to look over your work is just a really great way to improve your project. So reaching out to teachers, upperclassmen, just everyone in the community is probably more willing to help you in your project than you might think initially. So some things that our team wish we had done is, number one, definitely is just don't procrastinate and reach out for help earlier, because you'll be surprised by how many people in the community are willing to support you in your science pursuits. Another principle that I like to sometimes think about is the Pareto principle, which is this belief that the last 20% of work can often appear like 80% of the total contributions, mostly because you've done most of the foundational work, and during the last 20%, it seems like you can do more of the data analysis and in your project. So the conclusion is just not to procrastinate, because if you miss out on any of the last 20% of work, it might seem like 80% of the contributions.
You should also definitely get to know the judge's perspective. For example, what sort of rubrics are used, what are the grading criteria, etc. This can be especially important, especially if you're trying to get an award at a science competition. I know some science fairs are really, really sticky about your research journal. So things like that you want to know.
Know what you're getting into, whether it's time commitment, materials needed, or other stuff. You always want to over prepare. It's always better to over prepare than under prepare. That way uh, you're ready for anything that might happen.
Give it your all or don't do it at all. So effort is like a really big part when it comes to research and projects and all that.
Make sure you're building a good relationship with your adult mentor for your project. You really want to use their expertise and knowledge in your area of study to your advantage. Your mentor is here to help you, and they're always willing to answer your questions and provide guidance.
And finally, if you're interested in pursuing any kind of internship opportunity, it's important to start looking for those earlier in the year, especially in the winter and the early spring, because that's when many of the applications will be due. Next, we'll be going into some different research and STEM opportunities for different ages and research backgrounds. So Victoria, do you want to explain some educational opportunities for younger students?
Yeah, sure. So fun science educational opportunities for younger students include reading about science like nonfiction, science fiction, magazines like National Geographic, or science documentaries and movies. You can also participate in your school science fairs. You can also try, if you have a creative idea for an invention, just trying it out. Feel free to speak with your science teacher about interesting topics since they probably know a lot more beyond the curriculum than you would think they know. So, and go outside as well and just explore the outdoors and also check out local science museums.
Um, if you want to explore science and you're in middle school, here are some great options. Actually, these are all events that are available in high school as well. And honestly, some of them are a lot more robust in the high school revision. But they're on this slide because you can start in middle school. And it's a great way to build your love for STEM if you haven't quite gotten there in terms of wanting to do research. The first thing is Science Olympiad. It's a team-based competition with 23 events. There are 3 different types: lab, build, and study. It's a really great way to get hands-on experience, especially in the lab and build events, where you actually show up to competition day in a lab coat and conduct like chemistry experiments and whatever. Study events are also a great way to get a head start on higher level coursework. I personally did Science Olympiad as a middle schooler, and it really helps me understand what I liked and didn't like about science. Currently, Science Olympiad is online, so it's much more accessible. If you haven't started a team or don't have a team at your school, like just feel free to start one. You never know what might happen. The Science Olympiad team that I joined actually, like 4 years after its conception, made it to nationals. So definitely just give it a shot. You never know what might happen. Next is Science Bowl. This is a science knowledge competition run by the US Department of Energy. There's a buzzer system like that of on game shows. I've heard there's lots of adrenaline involved, and it's also a great way to meet people who are also similarly interested in STEM. I would also like to recommend Technovation, which is a team-based competition specifically for girls. Basically, you get to build an app and business from the ground up here. There's a great curriculum, and they also have a built-in mentorship system where you can get connected to people who work at major tech companies like Google, Facebook, et cetera, et cetera. I actually got to tour both of these companies when I did Technovation in my freshman and junior year as a high schooler. So yeah, it was just a really great opportunity, and I hope all of you check that out. Finally, there are also middle school divisions for Intel affiliated science fairs like Synopsis, which is the one specifically for the Bay Area. But it's always great to start early, and it's really interesting to see what your fellow middle schoolers can come up with.
Yes, so for research opportunities in high school, some general tips for if you want to find research resources or places to participate in research if your school doesn't offer any, you can try reaching out to your local science fair to participate. So for us, that's the Synopsis Science Fair. It could be different depending on what county you're in. You can also apply for different summer research programs or internships, as many offer financial aid. If you're looking for specific summer research programs, some great ones are such as the Boston University RISE program, the Summer Science Program, Cosmos, which is available at many of the UC campuses. And if you're interested in finding more, there are many published in some online websites, which kind of compile lists of the different summer research programs. If you're looking for funding for your research, as you might not have enough funds to get materials for your project, there are also many high school research grants that you can apply for. And finally, you can try contacting people at local universities, such as through cold emails, to see if there's any way you can get involved in their research. Also, there's a lot of ways you can find support within your community. You can try talking with your science teacher, who might also be your mentor for your project, joining a research club at your school, or just reaching out to any upperclassmen who you know have researched a similar topic.
And so with all this information, how can SparX give you more direction for improving your experiments and overall just help you succeed in your science fair project, research journey, or any other STEM endeavor that you may want to pursue? And so as a member or mentee of SparX, the first benefit that you may receive is open access to seminars like this one, where we will be presenting specific research topics and tips and experiences, and overall just giving everybody an insider look of the research process. In addition, we'll also be offering a mentorship program in which if you need help with any kind of last minute troubleshooting assistance, timely reminders, personal guidance, detailed paper poster edits, and overall just a deep search for any kind of errors, definitely do apply for the mentorship program. I'll be dropping the link to this Google form in just a minute. And so if any of what I just mentioned appeals to you in any way, please definitely do consider this opportunity as well. And finally, we will also be offering activities. And so our team is planning fun group STEM activities and networking opportunities. If you're looking for a research community and overall just a research network where you can share and exchange research ideas, then feel free to hop onto our SparX Discord to find research support. And with that, I will be dropping the link to both the mentee sign up form and the SparX Discord in the chat right now.
So thank you so much for coming to our first seminar. We'll be sending out a feedback form within the chat. So if you can leave us some feedback on anything that you felt you liked about the seminar, anything we could improve on, or topics that you'd like to see us go more into depth for future talks, then please make sure to fill that out. And if you're interested in contacting us or have any questions, you can reach us at these points of contact. We have an email, a website. We're very active on our Instagram and Facebook page. And finally, we also have a Discord, which is kind of a place for public chatting in different channels, similar to Slack, but in a more accessible way. So yeah, so thank you so much to everyone for coming to our seminar. And yeah, we would really appreciate if you could fill out our feedback form. And now we'll kind of be opening up the seminar to a Q&A session. So if you have any questions about anything that we went through, please feel free to message that to